Hi everyone. In this project, I worked on analyzing and predicting flight delays using real-world flight and weather data. Flight delays are a very common problem in the airline industry, and they affect both passengers and airline operations. Even a small delay in one flight can create a chain effect, impacting other flights, crew schedules, and airport operations. Understanding why delays happen and predicting them in advance can really help airlines improve efficiency. So basically, in this project, I combine flight data with weather data to understand how environmental conditions affect delays. And then I used machine learning models to predict whether a flight will be delayed or not. So the main goal of this project is to predict whether a flight will be delayed using weather and operation features. So along with prediction, I also focused on identifying which factors affected delays. Uh, the most and comparing different machine learning models and selecting the best model based on performance. So this kind of analysis can help airlines plan better schedules and reduce delays. It can also help passengers by giving more accurate delay predictions. So for this project, these were the research questions which I tried to answer. So So for the data preparation and EDA process, for this project, I collected a data from two main sources. Flight data was taken from the Kaggle datasets, and weather data was taken from the NOAA weather data set from the NOAA official web API. So after combining both datasets, I created a final dataset containing both flight and weather information. And the dataset initially contained a large number of records, but after cleaning and merging, I worked with structured dataset containing key features. So the main features I used here was flight distance, temperature like maximum and minimum, and precipitation, which represents rainfall, and wind speed, and some engineered features like temperature range. And also, I did some of the EDA visualizations, like for example, like arrival delay distribution, where it was shown by the high concentration were near zero delay. And also the second one was delayed versus on-time flights, and the third one is like monthly delay trend. So to improve the model, I created some additional features such as whether it was raining or not, and whether wind conditions were high, whether the flight distance was long. And one important focus on this project was weather conditions, like especially rainfall. Uh, like instead of using all seasonal variations equally, I specifically analyzed how rainfall impacts delays. This helped to reduce noise in the data and focus more on conditions that are more likely to cause delays. So by doing this, the model becomes like more focused and can be better to learn patterns related to weather based delays. And then I went on to the PCA section, and here I used it for mostly like to simplify high dimensional data sets while preserving most of the important information. So basically the PCA transforms the original variables into new orthogonal components called like principal components, which captures the maximum variance in descending order. So here, PCA, I used it to analyze like flight delay data and also weather variables to identify dominant variance patterns and simplify feature space before clustering. And then, so these were the data sets I used for PCA. And the data set used for PCA also included like quantitative variables such as flight distance, temperature and precipitation, and wind speed and arrival delay, as I said in the previous slides during the data prep. And these were my 2D PCI results. And then here, like you can move the cursors, and then you can find like the like delay status on time and delay status, like what were the delay status and delayed conditions. And then also these were my 3D PCA results. And then these are like variance requirement and top three eigenvalues. And then directly, I'll be going to the NIBUS model. So firstly, I apply naive-Bayes models including Gaussian, Bernoulli, and multi-nominal. So each model required different types of input data. Like Gaussian worked with continuous data, and Bernoulli used binary features like rain and no rain. So multinomial used discretized values. From the results, like naive Bayes provided a basic understanding, but did not perform very well compared to other models, mainly because it assumes all the features are independent. So and then I would go to the decision tree. So I used it with different depths like 2 to 5. So depth 2 and 3 were very simple and easy to understand, but they missed some patterns. Whereas depth 4 and 5 trees captured more relationship between features and gave better performance. From the comparison, I observed that the moderate depth tree gives the best balance between accuracy and interpretability. Also, the feature importance plot clearly shows that the weather related features like rainfall and wind had a strong impact on flight delays. So, like these were my decision tree comparison by depth, like the accuracy between them. And then I would go to the maybe the regression. So, finally, like I would go to the final conclusion directly. So finally, I use like logistic regression. This model predicts the probability of a delay. So the confusion matrix here like shows how well the model classifies delayed flights, and then the ROC curve shows the model had a good ability to distinguish between delayed and on-time flights. The coefficient plot also helped to understand which features increase or decrease the chance of delay. So based on like all the models, I would like at the end like I compared all the models using matrices like accuracy and F1 score. So that would be here around somewhere here, yeah. And then like from all these results, I would say like naive Bayes gave a basic performance and decision tree improved like little performance, and then logistic regression gave stable and balanced results. So overall, like decision tree and logistic regression performed better than naive Bayes. So maybe in conclusion, this project shows that flight delays can be predicted using weather and operational data, and rainfall and wind conditions were found to be important factors influencing delays, and different models perform differently. So where like simple models like Naive provide a baseline, and more flexible models like decision trees and logistic regression perform better. So one challenge in this project was class imbalance, since there were more on-time flights than delayed flights. This was handled using resampling techniques. So maybe yeah, like that's it. Like overall, this project demonstrate how machine learning can be applied to the real world problems, like especially like my project, like flight delay prediction, or maybe any other real world problems, like for us, like churn predictions or something related to recommendation systems. So yeah, so here I choose like flight delay prediction so that it helps airlines to improve decision making and reduce disruptions. So yeah, thank you for just going through my presentation.